Can you see my screen, my slide?
Yeah.
Yep. Okay. Hello, everyone. Thanks for coming tonight's event. I'm going to be talking about run deep learning in browser. Before we get started, I would like to introduce myself first. My name is George Chen. I'm a software engineer and architect. For the last 15 years, I'm currently working as a lead AI integration engineer at Cognitive Quantum. In my career, I have been building many different kinds of applications and systems, from a traditional client-server architecture to microservice systems, from CMS to medical robots. I have been observing the advances of AI and machine learnings, especially its adoption in our software industry. So why software engineer and architect should pay attention to machine learnings and AI? Actually, we are there to build product to deliver business values. Whenever it is applicable, we use ML AI to build applications for our users to handle the ML, machine learning and AI algorithms, models to our end users. Nowadays, there are abundant of computing power data is available, and the machine learning AI algorithms, they are already very capable and ready for us to use. However, there are also some unique features of AI and machine learning applications. As a software engineer, architect, we need to know them. We need to be familiar with them before we start designing, architecturing, and implementing application using AI and machine learning technologies. I'm going to use a live application to demonstrate that point, and just bear me, we will come to that later. And last but not the least, it's fun. It's actually really fun. And you're going to see how smart the people designing the algorithms and the beauty of mathematics. So as what I promised and Chen mentioned, I'm going to use a real life application to demonstrate using AI and machine learning in application development. So I made a Squid Game for, it's using computer vision for controlling the, we are in this game, we're going to use computer vision for user input. It's going to tracking users' hand movement and to move the characters, the players. And this application is running on the browser. It's supposed to be cross-platform, and to be able to run on a very limited computing power devices such as mobile phone. And since it's a game, the response time is crucial. You want to have it moving the characters to playable. And the data privacy is another consideration. We want to keep the data in the browser. We don't want the data leave our device. So, and we wanted to be able to work without internet connections. So when you design an application, design a system, you have to have all the functional and non-functional requirements there and give it consideration analysis to come to a solution, and then to have a design. So the design to this thing is, we are going to use HTML and JavaScript to build the applications, and that way it can run across browsers without the installations, without setup. And we're also going to use pre-trained TensorFlow Js model. And this model going to do computer vision is to detect your hand pose and tracking its movement. And we calculate the hand's movement to move the character. The more you move, the further the character moving. And as what I mentioned, for real life applications, the accuracy is not always the most important. You have to make your application usable, make the user experience good enough. So we have to sacrifice things like the calculation of your hand movement, the model inference. That means you sacrifice some accuracies, and we have to slower down the frame rate, the refresh rate for the videos. So I need to move it. Is any questions so far? So I come to the design first.
So George, could you show the demo again? I mean, run the demo again. I run the game.
Yep. Game is here. I link the game here. There's some just give it a moment. I think the model is loading issues for now. I'm going to show it at the end of the demo.
Maybe just maybe because you open the camera and that camera is allocated to the teams you're using right now. Maybe.
That's right. It's competing the competing. How can I? So I just need to turn off the camera, right? For now.
Yeah.
Yep. I think that's the cause. Yes, you're right. Can you see the page now?
Yeah.
So red light, I'm not moving. If I move, I just fail.
Yeah, but without sound effect, you need to share. I mean, all the friend can try it after.
Yes.
Meeting, because you cannot play your computer sound right now.
Okay. But you get the idea. It's used. Where's my slide now? So are we going to play the game at the end if we have enough time? But I just want to demo the idea. Is for this kind of interactive games, they're very crucial to have quick response. And you already see there's competing resources to control the hardware. And you won't keep the data privacy because you already saw my faces, right? You don't want this sent back to a server. You don't know where it is. And for all these things, you as an architecture, as a software designer, you have to take in considerations and to put the things together to choose the right tool, right architecture, and the right design to address these requirements. So we are using TensorFlow Js. We have the camera. We have a video processor to process the data stream captured from the camera, and this sent to a deep learning model. Is provided by Google as an open source pre-trained model. And this model can track your hand movement. You see in the demo, it's actually tracking your fingers, and there's 8 or 12 points in your hands. That's most likely the tips and the joint of your fingers, and to track their movement. And we are calculating the movement as an input for your character's control. The more you move, the more your character move, and you have to finish the running before the time runs out. And we have a game logic module, and you put all the game logic more in here. That means the win and the lose, and your current progress of the game. And we have a page object to represent the UI. So you're going to see machine learning and AI is only a small part of the whole system. Probably in here, probably less than 1/4. The software, all AI and machine learning application ultimately is software applications, right? So my focus as AI integration or probably AI machine learning practitioners is always focused on bring the AI and the machine learning into productions to make products for our end users. So TensorFlow is one of the tools we could use for this kind of applications, this kind of design. So what is a TensorFlow Js? I think most of you have already heard about TensorFlow, right? TensorFlow Js is an open source JavaScript library provided by Google. It enables build, train, and host machine learning, deep learning models in your browser or in Node.js. It provides a high-level, user-friendly API. So it provides the building blocks, and it's easy for beginners. Even you're experienced, it still can appreciate it simplicities. But you can always go lower to the core API. And all these things depends on WebGL to interface with the hardware, CPU, and GPU. If you're running in Node.js, you can access the server's CPU, GPU directly through the drivers. So how we build a neural network, because in the demo, we are using a pre-trained model. And you can either using a model and build on TensorFlow or somewhere else and saved and load into JavaScript from your Tensor.js, or you can just build one. But ultimately, they're the same. It's a graph with weights. So let's see how we can build a very simple regression models from the scratch. I have everything in JavaScript in the code pen, but before we jump into the code, I want to show you the steps we're going to take. It's a very common steps for training a deep learning model. The first, always data. You have to prepare your data. So in our, we're going to fetch the data from the data source, and then we're going to remove those invalid data. After that, we do pre-processing. Pre-processing involves several things inside, such as normalizations. Then we have to transform the data into something our model can use. That means transfer to tensors. And tensors actually just abstraction to high dimension arrays, and that's kind of the input to our models. Tensor.js can recognize, can use. And then we build our model, train our model, and we evaluate its performance. So here's the code. I'm using CodePen, and the result actually live updated You always, if we are familiar with HTML and JavaScript, we are link the Tensorflow Js, and we link the visualization libraries here. That's pretty much the import, like what you're doing in Python. Now here's the code. I use one of the Colab, but I rewrite it with something adding to it, and I have break those steps into functions so easy to follow. As what I said, those are common steps. We are fetching the data, we get in the data, and we do the cleaning, and we do the visualizations. So you have to be familiar with the data to get a feel to detect anything as abnormal. So our data is, say, let's see, the beauty of JavaScript is it's so easy to use. This is the data set we're going to use. We have a bunch of car informations like the cylinders, the displacement, horsepower, and weight and things. We want to use this information to predict the miles per gallon. So this data actually is a completed data with labeling. We will be able to use this for training. And then once we get a model, we can input some like horsepower and to predict its MPG, right? So we get the data and we're using a filter to remove the embedded data. It's pretty much just incomplete. And here's the pre-processing. We have the data and we have the input, or you can call it features, and we have the labels. Then we transform them into tensor, and then we normalize it. Normalize means because you're going to see the weight is from 0 to 5,000, horsepower from 0 to 100. We are rescaling it. If you're really good at the math, you can see we are rescaling it from 0 to 1. That's called normalization. It could greatly improve your model performance, and this is a very common practice for almost every models. Here's the function we build the model, and we come back later, and then we do the training. So you're going to see we have 3 layers here. That's why you call it deep learning model, because you stack layers one by one. And that's called a network or graph.
Sorry,
we have 3 of them here. Sorry?
Sorry, could you adjust your background on this IDE? It's too dark.
Oh, you mean the code is too dark?
Yeah, the code side. Yeah, not zooming. You just click here.
Shit. I don't know the color.
Yeah, or you can highlight. I mean, something important you can.
Yeah, I can highlight it. So let's take a look at the model itself. So we build a sequential model. This sequential actually just a group of your layers, and we're adding an input layer, and we have a hidden layer, and we have an output layer, and we have this summarized summary of our models here. And this is provided by the TFJS VIS, the visualization library. And then we're going to compare. We provide a optimizer, ADAM, or SGD if you like, and the mean square error. Those are some kind of very common. optimizer function and the loose functions, and we're tracking the metrics. I don't want to spend too much time on the deep learning details, and we can have other continuous talk over it, or you can just go deep learning AI to take their free courses. It's quite useful. But that's the general steps. We prepare data, we train the model, and we evaluate it. So you're going to see this is a loose. Loose means for regression model, this loose just the MSE. That's the pretty much like the distance between your prediction to the real truth, to they call ground truth. And pretty much you get a feel, and if you like, you can just take this code and play by yourself. So we don't have time, we don't have much time spent on this part. It's already 24. So let's back to building applications. So fundamentally, you just have a kind of a model, a graph like that, stack over stack, and you are building an interface over your model. That means inference. And then you give a data as input. For our example, we are giving our camera videos, and then our model going to analysis your input and identify, that's called object detections for your hands. And then to using the hand landmark model to try to find the key points on your hands. And then we do the calculation, and then we feed it into our game as input, like using your hands and camera as a gamepad thing. But we are building an application for players, for real users. This is not to publishing a paper. So you have to consider way more than just the accuracy, just the kind of loose functions. We need to build something reliable, maintainable, and scalable. All these things are software engineering, and all software engineering principles should be respected. If we back to our design, and we can clearly see each module is for specific functionality groups. That's called single responsibilities. And we are using page object. That this is a design pattern, and I gave a reference in the back. It's very famous design patterns, and our game logic encapsulated in this module. And we have our AI module, that means hand pose recognitions, in another service, another module. So each module, they have their kind of encapsulated and interface with other component with API. That's called coupling, right? We ensure the loose coupling, and we have invention of control. The page object actually is injected to game logic. Those are software engineering ideas. It's very, I think most software engineer are going to understand and use it daily. So as what we said, as what we already see, is beyond for AI and machine learning itself. We need to have something, application, the system for our end users, and to address the business objective to deliver business values. So the real challenge compared to the lab is if you are following Andrew N, he's very active in promoting so-called data-centric machine learning and AI. So their production environment is quite different than labs, and the production applications has very different objective, a goal, then lab. Lab is they're going to squeeze every final possible performance to get state-of-the-art model and to get the publications. But for production, you have to compromise the performance, compromise for accuracy, for what I said, usabilities, for your scalabilities, for maintainabilities. And you have other issues like data drifting, like a domain drifting. Like here, using our games, actually these games with a different screen resolution, probably iPhone or Android or my MacBook, they all have different screen resolutions. So actually it's tracking the movement quite different. So it could be fast on one machine and very slow in another one. I mean, the character movement, right? And for JavaScript, you don't have control over timing. This time is not just say the time display though. This time is just for computer, you have to rely on hardware to really provide process control for the time. So our time in the JavaScript are all actually promised. It's just the estimated actually. And also browser support things, the media API, the WebGL support, they're all different and they're also light conditions. They're all kind of an example of data drifting and sometimes domain drifting as well. So any questions so far? I think we are running out of time. But if you're interested, we're going to have this slide post on our website and with all the links. Those are regression models, the game, the game, you can play with it, and also with the source code of the game. So if you're interested, you can take it. Feel free to modify it for your own purpose. And the model we are using is from Media Pipeline. Here's the link. And the things that talk about machine learning, software engineering relation things, you can find from this most famous paper, Hidden Technique Diet in Machine Learning Systems. It's a good reading. So yeah, that's 31 minutes. Good. Not too bad. Good.
Actually, you just spent about 28 minutes because I used the 3 minutes.